Hello and welcome to For Whom the Cell Tolls. I'm your host, Professor Keenan Hardert. I'm joined by Ranger German Shepherd and Scout Pomeranian, both sleeping, my co-hosts. But before I start, I just wanted to shout out a couple new things that I'm up to lately, which is go follow me on, I think I post on LinkedIn and Instagram the most, but I'm starting to do some more articles, things like that. They might be fun if you're interested in higher ed, science type stuff like that. But honestly, the podcast is still where I'm going to do most pure science stuff. That said, I did do another sort of video show with 9 of my students. I did a podcast, quote unquote, but if you go to the website and the YouTube, you'll find it's called Degrees Between Us. I thought it was just a fun way to highlight what all these really good students are up to in higher ed right now, what we're gaining from that, and so on and so forth. They're really good kids. You'll enjoy getting to know them. It's sort of also a way to showcase who they are and that they're real, because most of them are applying to grad schools type stuff, med, dental, all that. And having a video recording of a conversation is so much better than a letter of rec that is somewhat fallible in the age of AI now, right? So, getting on to the real stuff coming up here. Yeah, that was my ad. I haven't done an ad in forever. The real stuff for the episode. Obviously, this one's a bigger hit and it's going to get some attention and, et cetera, et cetera. But as we crossed 40,000 listens the other day, not 400,000, 40,000 downloads and listens. I started this podcast when I was just a postdoc at Mayo Clinic. Wanted to teach more, but now I teach full time, and then I ran out of time for the podcast. It's summer though, and I finally have some moments. So this one is here to sort of dive in mostly on the science side to go into why are rates of tumors rising in younger generations of people. That's going to take us and address the event from 2021 and 2021, which is mRNA vaccines, which again takes us to the title, what the hell is turbo cancer? And we're gonna dive into what that thinks it's trying to mean, I think, and kind of go from there. So, you guys ready for this? I think let's hit it. Okay, so I'm reading Yuval Noah Harari's next book called Nexus, about human networks and stuff, and kind of the way humans thrive is that we are social and need information to exchange between each other. Information, science, truth, data is one form, but the favored form of humans is stories, mythos, exciting things, gossip, right? The problem with social media these days is that, well, that's pretty rampant, to say the least, right? We crave stories and fun ideas and stuff. And the stranger the story, the more exciting it is. And the more controversial something is, the higher social media platforms are going to push something, right? Data is info super boring. The 30-year-old diagnosed with colorectal cancer or stomach cancer is a lot more exciting in a sick way because it's a very rare event. There's no tweets for all the 60 or 65-year-olds that also got diagnosed, and there's probably 100 of them compared to this one guy. Now that said, this is a very important part to recognize. Stats predict populations, not individuals. Individuals are special. Genetics predict populations, but the individual, they have their way a lot of the time, okay? So you got to keep that in mind. All right, first, we get to tail into some cool stuff with vaccines, but let's just introduce the main bits to start. Essentially, the way these things work is we inject a bunch of little pieces of amino acid sections of diseases that are harmless. We make sure and test it and, see all that good stuff. We hope that this bit gets displayed by MHC1 in the cell that it's absorbed by, and then the immune system's like, hey, this is foreign. Let's start making a response to this and make some memory. Now, the good news is that memory is made without massive impact, as we've seen. Otherwise, we all would have died from all the vaccines, right? And, remember, the first way that this really started was when we had smallpox. We eventually just said, hey, let's smear this cowpox pus on this kid. Shove, shove, shove. And then the kid eventually got smallpox, and he did pretty well, right? Now remember, and I've said this on this podcast before, that poor kid did end up having a lot of developmental delays, died at 21, stuff like that. So smearing live stuff is not the ideal way to do things. We started to get better at this. We started to refine vaccines from like 300 to 500, pieces of fake stuff. It's down to like 5 to 20 now. So the responses are a lot more measured. And I mean, data and empiricism can get you pretty far in terms of safety, things like that. And I mean, overall, you got to look at smallpox, even though we don't think about it anymore because it is eradicated. You got to look at smallpox for what it did to history. You'll see some good. I can't remember who the outdoors guy. He's always on Rogan. He talks about how when the conquerors came over, conquistadors, all them, and they gave smallpox, and then they went back. The smallpox spread for like hundreds of years throughout North and South America, and that when people landed kind of on the coasts, kind of on the East Coast, they were looking at a native world that had been erased. It was like a ghost of its former self because so many had died. The smallpox vaccine stopped that for what it would have happened to all the rest of us. And it doesn't erase the fact that that was a tragedy and that was history showing its ugly teeth. Now, given all that, let's say that we encounter a strange global epidemic and it happens. Should we blame every bad thing that happens on this global event I'm talking about, let's say, on the global event after it happens? If you moved into a new house, and you're hypochondriac, and 2 weeks later you're like, oh my God, I'm going blind, I think. Is it because you moved into the new house, or is it just that you have about 6 to 7 issues a year that you freak out about? Not to say the house couldn't have an effect, but when you are looking for something as the cause, we immediately attach to the big events on our mind. We rarely attach to the small events in our mind, like how many times have you exercised this week, or what have you been eating the last month, okay? And we're going to get to that later. Okay, let's look at that global event for ourselves, and that was the COVID pandemic. And I'll just say right here, I'm not the viral biologist person. We're going to talk about cancer in a sec, but I got to tell you about mRNA and how mRNA vaccines are going to factor in with cancer, okay? Because I think I've mentioned this on the other post. So, quick little fun biology time. Remember, in your cells and then in their nucleus, there's DNA. It's good as storage. It's safe. It's good code. It's really locked down, okay? The double helix makes sure that that's a very safe molecule, okay? It can go through meiosis. It does crossing over. It's the information. It is the sacred text. But to use it, you have to take a copy from it. mRNA is transcribed through transcription, and that's all that epigenetic stuff we've talked about before. A piece is taken from the sacred text and copied, and the sacred text is left alone. That copy is what goes on, springs through, and then is translated by our fun little ribosomes to make the proteins, the real deal stuff, the receptors, the hormones, like all the stuff that makes genes for us. It's proteins, they do it. They came from DNA, but they physically were translated from the language of nucleotides to the language of amino acids into proteins that actually do things. And the mRNA was that conduit. Okay, so like we talked about, we've been talking about how vaccines very much were like pieces of protein, and that's good. They've done pretty well for us, good for us. We don't die from smallpox anymore, hooray. Now the mRNA was new tech, it was. And the story goes that, again, we essentially had vaccines from SARS that were using the mRNA tech, and that is for whatever reason it is. I can't remember if it was for the fact that these mutate kind of fast, et cetera, but that's the beginning that we had. So, hooray. Turns out that if you want to instead skip the sort of protein raw step and you want something that's a little more dynamic potentially and a little more, you don't have to load up as much in the cells, let's call it. If you use mRNA, put it in, and it is then translated in your cells and then still just displayed on MHC1, that's kind of just the same thing that we were doing with proteins, just with this sort of extra step. But now we can change the mRNA so much easier, and It's much more dynamic. We can change. Have you noticed how the vaccines have changed depending on, Omicron, Delta, like all this weird stuff? There's a certain flexibility offered by this tech. So, cool. Now remember, this stuff doesn't even go in the nucleus, doesn't edit your DNA. That's like the CRISPR and gene therapy stuff we talked about. That's when you get a harmless virus, make sure you integrate this new DNA, and then have that new DNA maybe sprout a CRISPR, and then that CRISPR goes and does stuff, right? That's a whole nother conversation. That's gene therapy. Good for that, and there's a whole episode on that and how it can help us. But let's look at the future. And I think I've told this story on the pod before, but you might be new. For the longest time, we've never had a way to control the immune system to target cancers. Our immune system is very good at that, actually, when it is healthy. It can find cells that are unhealthy or expressing mutated proteins and be like, this is not self, this ain't me, it's time to die. Thousands of precancerous cells are killed by your immune system, okay? Every one of us listening right now has a couple precancerous cells running around, probably more than a couple, and they're being hunted. And hopefully they're hunted enough that they'll either die or simply just never be able to emerge. So, looking at that, it's always been hard though, because cancer is built of all the tissues of your body, right? So there's not really a general target every time. That said, there's probably 50 genes out there that they get messed up in a lot of general cancers, or at least the higher population ones. What if we had a vaccine that didn't have one or two potential, pre-targets or premonitions that it could give your immune system, but 30 to 40 targets in one? You can't fit that many proteins into a single thing. It's too fat. But mRNA is small. And mRNA can load right in. So this comes from when I was at UNMC in my PhD, talked to Keith Knutson, a guy from Jacksonville Mayo Clinic, and he gave the grand rounds, and we were at the bar with him after of the seminars, and we were all asking him his student stuff. He was like, what do you got next? What do you got next? And he's like, there's one thing we're working on, but we've never tested the tech. It's a cancer vaccine. But we've never seen the effect of using mRNA as the conduit instead of just pure protein before, and so we're still kind of waiting. COVID happens, and we see that the mRNA tech, it works. It translates. So, imagine in 5 to 10 years, we hear that we can potentially slash the rates of cancers in half by prepping our immune systems with this. I can promise you things are going to get really weird in the social media storyscape, things like that. I got to tell you, but here's what I want to leave this section with, is that there is so much hope and so much cool stuff down the pipeline, okay? We're so damn close to figuring out so many of these things, I promise. We've already done so well with what the genome unlocked for us, but we're able now to change so much more. Specifically, the ability to fold our own proteins. Imagine making an enzyme that chewed up cholesterol, or making a receptor tag that, covered certain receptors so you didn't overinflame for MS or RS patients maybe. That's kind of where we're closing in on. So I do think that we're maybe half a decade or a decade away from one of these big busters that just blows the whole thing back open. Now, let's address the other fun guy in the room, COVID itself, okay? Like I saw an immunologist, she said, it's not that this virus is so deadly on its own. It's that, imagine spilling water on a concrete sidewalk and watching as the water goes. If the concrete block has no cracks, it just washes into the grass, you're fine. But if the concrete has cracks, it finds it. COVID is fast and sneaky. It sort of derails your initial alert systems, and if you get too big of a load, it is then found by your immune system, and everybody loses their minds, as the Joker would say. And if they lose their minds near the heart, near the lungs, or the partners that your brain has get a little too upset, that's where you see the toughest ones, the toughest symptoms. And I do want to focus on the fact that to this day, we don't really have a good treatment plan for people that have undergone this sort of long COVID brain fog. if y'all have ever been hungover before and you feel that anxiety and like the ability not to focus, think straight, that's kind of that's a good mimic for what overinflamed brains are. Because remember, when you're hungover, your body's kind of resetting and the inflammation's not happy with you. So that also wasn't a good thing, when the fact is a lot of us have habits that aren't healthy. And I'm calling myself out on that too. All right. Now, little halftime shout out here. If you guys want to know my personal cancer biology conspiracy theory, here it is. You guys ever see the maps where it's like rates of cancer being really low and like higher age in the Nordic countries and in Minnesota and in Canada and stuff like that, right? I would say that this is due to the winter heat shock proteins, I think. That's what I would guess, is that like when you're really cold, the ice bath things? I think that like the winter maybe activates that in Nordic types. So I'm gonna that's my fun story that I'm gonna guess on. That's not even a hypothesis though. That's just literally a guess out there. So I would go ahead and say that. As you guys know, I still record this basically just out of my house, so my laundry just went off. So just skip ahead about 30 seconds. Ranger, it's okay. All right, yeah, back. Sorry. The life of summer. Sorry about that. All right. Anyway, so let's dig in though. Then we've seen the turbo cancer tweets, and again, it's tough because stories again draw to our human minds, and to see a tweet saying my personal friend who I won't name, etc., now has this cancer and it's killing them, and it happened out of nowhere. It's turbo cancer and it's everywhere. Let's start with a few things on this. Number one, are there certain cancers that grow faster? Yeah, definitely. There's cancers that grow really slowly and kind of hide. It's actually the middle ones, those ones in the middle that are kind of balanced, that are dangerous. The fast growers are actually really stupid, and they often trigger the immune system or are really susceptible to our therapies. Great. The slow ones are also tough because they can hide pretty well. But they often enough kind of can just go dormant. Like we've talked about with follicular lymphoma and some of these indolent ones, they can just sit there, and that's actually the treatment for the most part. So there's that idea. Are cancers, some of them, faster spreaders? Yeah. Here's the other, again, tough thing, is that the hardest cancers are the ones that show up when it's stage 4 already. Pancreatic cancer historically has been nearly impossible to find at stages 1, 2, or 3. It's usually when a tumor spreads to the lung, the brain, the something, and they find out the source is the pancreas, because we're rarely digging around in the pancreas. So that's when you hear about the patients that are like, and they have stage 4, oh my God, where'd that come from? It's been there for years, growing and learning, evolving, and eventually one of these cells made the developmental transition to be able to circulate and find a new home. Seed and soil hypothesis, like we talked about before. So that's kind of the tougher one. And the thing to remember is that like better diagnosis is really going to help. And even in the paper that we're about to kind of dive into a little more, this is Sun 2024. It's from the Lancet, and she and the rest, everybody says differences in cancer rates among adults born between 1920 and 1990 in the USA, an analysis of population-based registry data. And again, these, let me see affiliations, yeah. So yeah, again, we're American Cancer Society, Georgia, and Calgary, and some of these other places. Okay, so the good news with something like pancreas is that the mortality is actually going down because we're finding it more. We're doing better at this. Some of our like seeking stuff is getting amazing, like the custom dyes, different lab tests that people have pioneered. Excellent. So this is going to be a very strange thing that we are going to find more of these, But a sharp decrease in the mortality is actually a really good thing, because if you get pancreatic cancer and you find it at stage 1, 2, or 3, you're pretty good. I'm not going to say you're great, but stage 4 is that's a whole nother thing, like we talked about. Okay, but going into the Lancet paper, and again, there's other papers that do well looking at this too. There are some cancers here that they're going up in incidence rates in younger cohorts, people born in 1990, 1980, things like that, like Conair, Gen X, and Millennial border right there. Let's take a look at some of them. Small intestine, thyroid, kidney and pelvis, pancreas, liver, myeloma and leukemia, so different stages, but still both blood cancers. Let's take a look. Esophageal. And there we go. Okay, so those are the main ones. And most of us have seen it's the colorectal stuff that keeps popping up again. So, given everything, and back to that example that I made where it's like, if a large event happens, everything that follows it is often going to say, it must have been that thing. And that is tempting. And I'm just going to say it here. We still need to study shit, okay? Nobody's saying that everything's set in stone, trust me. But there's been a lot of other things historically under the crust since before COVID, long before COVID, that has probably been setting the stage. So let's meet a few of these little guys, okay? And again, this is broad and it's boring, but it's often the boring answers to the big stuff tend to be the most likely. And that's kind of just where we're at right now, is that we're still investigating why. And I'm just here to tell you, it often is just the boring things. Some of these aren't too boring, though. So let's take a look at people born in the 1980 to 1995 range. I'll take you back if you're a little younger here, okay? Now, who remembers in the 90s what kids used to eat in the early 80s, right? Those kids meals with like the brownies made of just like goop. like the ingredient list on some of these microwave things was just insane, right? This was, I would say, maybe the rise of the sugar craze. This was, pop's always been around, but there it is. Hey, there's a reason the amount of sugar is now included on the nutrition thing. Who's aghast when they actually check the amount of sugar you eat? I've even tried to get below 50 a day, that is not easy. And then we get into the whole sweetener thing, et cetera, but I'm not going to touch that right now, because I'll get found by the big sweetener people. All right, here we go. The more you keep screwing up the human diet, the worse things are going to happen. And can you guess why? My students in pathophys and cancer biology and even pharmacology, we always get into the discussion, what's the perfect human diet then? And this is going to come from my broad understanding of the safest possible microbiome diet. And there's our first spin at the word. The reason you're seeing a lot of these cancers pop up, most likely, is because finally being studied is the microbiome, and the composition of who gets cancer and who doesn't is very different. If you have a diverse amount of species and you have good fibrous species, let's say, you run less risk because your body is less susceptible to rampant, uncontrolled inflammation. Let's go back to remember what inflammation is. It's not a total boogeyman. We just talked about how your immune system does have to inflame if you get a cut. It does have to inflame to save you from an injury inside you. But if you're constantly taking this stuff in and you're constantly perturbing your immune system and it always thinks something is damaging you and hurting you, it's not going to be good. So, think about pollution or even just smoke in the lungs, right? Those particles get in, they get sort of stuck in the surfactant that attracts your neutrophils and your angry guys, and they sort of surround and kill them. The inflammation is going to happen there all the time, and your poor bodies, remember, these cells don't know what century they're in. They think that something's invading your lungs. They don't know that it's a pollutant from the farm or the factory down the street. No offense to farms, sorry, that was a little cruel. They will seal that section off and begin to attack. And that is chronically, that's just going to kind of cause them to be in this very angry, mad state. Having a microbiome that teaches them, calm down, wait for the real thing. Not only are you not going to have as much bad dietary inflammation like pieces going in, if you feed your body the right way, you're going to have species that remind the immune system because they have a partnership with those T regulatory cells that calm everybody down. That partnership's been building in mammals, our ancestors, whoever, as long as you go back, for millions of years. We're finding that that's the key, is this microbiome immune system communication. That's the key. So, what is the perfect diet? My students are always mad at this, and it's not like I adhere to this either. My guess at the perfect diet is somewhere around like 80 to 90% fiber. So like a ton of vegetables, beans, legumes, good, okay. Get some fish in there and some meat for the remaining amount, hooray. This whole time you maybe had a little bit of sugar because you found an apple tree or something. Oh, and by the way, salt, nah, you can't have a ton of that on your food. Again, that's the sort of joking extreme version of this because the species inside us, like Akkermansia municiphala, they need the fiber, needed to feed them the right things so that they proliferate, kind of like an ecology question, right? And yeah, just buy 2 pounds of chia seeds and just toss those things on there. Just pretend they're pepper flakes, right? I did see an article basically saying like, okay, Gen Z millennials have solved their protein problem, but it's the fiber problem that keeps showing up, okay? So let's keep looking at some other stuff that has changed in the last 20 years that would indicate some issues would be brewing in a sort of epidemiology way in cancer, okay? All right. Have we gotten too obese? Are humans too sedentary? I think both of those questions, a lot of you are probably nodding and be like, well, yeah, overall, probably, yeah, right? Now, some of that's due to circumstances. That's a lot due to, like I said, microbiome comes right back to that, where certain fiber things are going to fill you up better, even though they're the same calories as a certain sugar thing, right? Okay, next. Who feels like our sleep patterns are different in that 20-year, that 1980 period to now, anybody born in there? How many more people work strange hours or stay up at night? What keeps us up? Video games, screens. And I hate to tell this to the overnight crowd because I did work an overnight in my first job too. Your circadian rhythm genes are extremely important, and they will dysregulate and they will start causing chronic damage to your cells and provoke them to be predisposed to tumor genesis. That is not an ideal thing to hear, and I know. Another thing that we're seeing, and again, don't shoot the damn messenger on this, but reproductive changes and birth control, things like that, they have their, anytime you're doing any endocrine up and down stuff, it's going to have an effect. I'd say what to look out for more is if you don't need to take finasteride and you don't need to take testosterone, please don't do it. Messing with your hormones like that is it's gonna do some strange stuff potentially. Okay. Also, classically, we've done pretty well as a society with air pollution. I'm not going to lie. Have you seen the pictures from the 70s of LA and stuff? We've done better with that. But again, stuff in the water, stuff in the air doesn't help, and it just kind of keeps seeming to be more present. But again, I need to look at the data on that to be sure. Last one. Well, not the last one, but no, let's do one more. We've talked about C-sections before. I'm a C-section baby. And we've talked about the immunology of like breastfeeding versus formula. There's a bit more, and I sound like a naturalist person here, but going through the natural birth is going to expose you to the mom's microbiome, and that's natural. And I don't want to tell you how, but you kind of know how, I think. Next, again, mother and offspring exchange a lot of sort of immunological shadows and prep during the breastfeeding process that formula doesn't quite replicate. Now, again, Nothing wrong with either. Ultimately, those are kind of smaller fish since they're not as common, and it's just less big. Because we're getting to the two final ones. Well, actually, I should do one more. It's not huge. It seems that the sedentary and the low exercise paired with alcohol and then paired with the bad diet stuff, alcohol is again sort of rearing its head as the carcinogen it is. And as somebody who probably has too many beers, I don't like hearing that. But when our body is already sort of overwhelmed with the stuff I've been talking about, and then booze gets in the picture, and then the liver is like, I can't handle this. This is ridiculous, man. You've been eating this crap. You've been breathing in some weird stuff, and then you poison me. It's the hardest working liver in the galaxy, Morty. But if it has a hole in it, it's not going to do super well. Alcohol is complicated because it will start to have its effect, and it's not just going to be the pure damaging effect of some of the molecules it has to convert into while the liver's doing its job. It's that hangover feeling like we talked about. It's the inflammation across your body and that buzzing that you feel on a hangover. It's like, oh God, your immune cells think something is killing you. They don't know that that it's just the stuff you had. Now, my thought process for this, why alcohol wasn't the same killer that it was in the past, maybe if we're going to say that, and maybe it was, and I'm just kind of skating over that too much, is that, yeah, when you pair it with too many other strange things, it gets loose a little worse. I mean, tell me or tell me not. Have you had a worse hangover after you've eaten a bunch of crap? Probably is my guess. But we're all kind of different in that. All right, the last big daddy. Here it is. You want to know the real probable biggest reason? Well, okay, I'm not going to stand on a grandstand here too much. The likely big thing is that in the 80s and 90s, antibiotics were massively used, okay? In the 2000s, I had acne and I was prescribed, and again, it's not the person's fault, science evolves. I had antibiotics prescribed to me for like kind of some chronic acne. It was just like, just take this tetracycline for the next 4 months. What do you think that antibiotic did to my microbiome? Everything that was a tetracycline target died. And it was replaced, likely, if you spray your lawn, what happens? Weeds come up, not new grass. It takes time to get the grass back and the native plants. So prescribing antibiotics when it's clearly a virus, prescribing antibiotics too much, it's probably, we're doing better now, but that is where a lot of this microbiome bad stuff comes from. Now, to be able to restore that, you have to have that right diet. You have to still maintain the exercise, because remember, exercise does wonders to train your immune system to what true and good inflammation is, training inflammation. And then it helps your body when it encounters the real thing, okay, among many other things. So do go out there and do some squats. Now, let's just say it though here. Antibiotics are miracles. Said and done, okay? Gangrene, all that stuff. You remember World War I, Civil War, that stuff eating up the leg and stuff. I mean, you see it in remember in Game of Thrones, Khal Drogo gets cut, and that's like totally it for him. That was the reality back then. Antibiotics are miracles, okay? But they got to be treated more, and I've said this before, more like chemo. Go read 10% Human if you can. It's really good. And again, microbiome stuff is very complicated because it's essentially ecology inside the organism, evolution inside the organism in these worlds, essentially. And they have so much kind of connecting. The microbiome of a patient who does well against chemo versus one that doesn't, they're different. They're emerging. Different species are showing that they're more beneficial for us, and they help us through that time. The microbiomes of people who get versus don't get cancer are starting to be parsed out, okay? And kind of the darkest, craziest thing, do you know that tumors, when they really take hold, they form a microbiome around them and feed a microbiome around them that helps and facilitates them. They have like a shadow microbiome to themselves. Isn't that messed up? If they're in a tissue that allows for bacterial species to be present. Okay. That was a lot. We touched on a lot of fun stories today. I guess the last little fun reminder is that we we have each other. You know, it's not midnight yet. The world is this bright, beautiful place. The wild animals that we have here. You know, what we can build together is incredible. New things and things we don't understand will always be scary, though. And I think I brought this up before. Stocks and money are terrifying to me. I don't know how this works, okay? I just buy and hope to God it helps okay. I remember I read that Graham book, about 600 pages on how to be an investor. Guess what basically at the end he says? He's like, if you don't buy a stock if you're not ready to basically know the business itself and know it's legit. You're an idiot, then just buy mutual funds. And I was like, wow, 600 pages later, and I'm dumber than before. Stuff's scary that you don't know and you don't control. And stories can take over because they're what humans and all of us love. And you just got to remember, be careful, especially now, because stories can be told fast and stories can be told by fallible things, Twitter accounts, bots, things like that. And I mean, let's be honest, AI is around and it is fallible. Be very careful, okay? Thinking that it's infallible is that's the danger right there. It's a very good tool, but remember, it's a tool. It's a little assistant. It's a little friend. Hooray, good. But again, I'm not going to get into the AI debate because a lot of people are angry. But here's what to remember in the storyscape that we're currently in is that social media, 90% of social users are lurkers. Like, they never make an account. Like, I know people who've been on BuzzFeed for 10 years, and I was like, oh, you must have, like, you know, saved articles and, like, quizzes or whatever they do on that. And they're like, no, I've never even made an account. I was like, you've never even uploaded a thing? No. It's crazy. 9%, and this is usually where I fall in, is people, users that like things. They actually click things. If you like things and click, you're actually among the 10% of social media users. The 1% that's left are the people that comment, and they do a bunch of it, okay? Do not let the aggressive engagers, the loudest people, be correct because they're loud. Seek the Stoics, seek data, seek wisdom, slow down. And if anything, honestly, and I'm doing this on your phone, and I'm sorry to contradict all this, you know, putting the phone down once in a while has helped me a ton the last year. I'm going to guess that we go into an age where we do put the phones down and stuff. Because here's the other thing that supposedly is going to really hurt you physiologically. You know, humans have instincts to be accepted and to be in communities. Number one, that's going to draw people into very dangerous communities a lot of the time. Number two, if you don't have a community and you don't find people, your body does have physiological reactions to that, and it is unhealthy. But I'll be the first one to tell you, it is very hard to go make that community. You know, being in a room with new people, it's never easy. But if there is a possibility, that is also something that I would say likely is contributing to this sort of strange rise right now in issues. But again, that's one that's a little further off and doesn't have enough data and study to do as much as I want to do with that one. All right. So yeah, like I said, if you want a happier tone, I did do a new podcast show, The Degrees Between Us. Yeah, I think the link to my website's just down there. And again, it's not a real website. I just had to use Weebly. I don't have enough money to buy a real website. But it's fun. And I've been posting some class data stuff and articles on LinkedIn, things like that, and working with some other fun people. So I'm really excited I did an episode. I really need to do this a lot more. But go find me on the other stuff. I post on Instagram and post stupid memes once in a while that my class and I make. So we've had some fun with that. But in the meantime, again, take care of yourself. We are in this together. And I will hopefully do a few more of these coming up. But yeah, I mean, if you have friends that are interested in stuff like this, feel free to share. Don't get fucking angry and weird at me for telling you what I wrote down in my notes. Sorry if I sounded preachy or not. I do talk a lot, so probably someone in here that's weird. Anyway, I think it was fun. And remember, the truth is often, unfortunately, very boring, but often safer. And again, pursuing that truth is a journey that's lifelong, so it's never over. Hooray! Thanks for listening. See you next time.